Hi, I'm John Crandall.
And I'm Brian Warback.
And we're in a hotel conference room today, and we're getting ready to set up for a workshop for the Center for Process Analytical Chemistry. And what we're going to do is show you how easy it is to set up a Falcon Analytical CALIDUS micro gas chromatograph. As all chromatographs using a flame ionization detector and all chromatographs in general, there are some utilities required to be able to operate.
First thing we're going to do is we're going to take this pump. So we have a little air pump because all flame ionization detectors require air, and use that as a quiet way of generating air for this process.
It's called Super Silent 20A, and the nice thing about this little air compressor is it has enough pressure and flow capability to supply 2 gas chromatographs with up to 2 flame ionization detectors each. And essentially this is going to provide the compressed air for the next utility we'll talk about, which is hydrogen. In the case of flame ionization detectors, it's convenient to use hydrogen both for carrier and of course you need the hydrogen for the flame ionization detector fuel.
I'd also say if you have normal gas supplies, then you can always use those, but if you think about it, if we can get rid of gas cylinders in the lab, all the demurrage costs and the danger of handling tanks is fairly extreme. So it's nice to be able to use units like this. It gives you a lot more flexibility, a lot more portability, and placement capability in the laboratory.
Okay, this is the system that will provide not only hydrogen for carrier gas and for the flame ionization detector, but we're going to feed compressed air to the back of the Parker-Ballston FID gas station. I believe this model is 2500, and it has enough capacity to both generate hydrogen from a little bit of water that we're going to put in the side here. A little bit of electrolysis makes the hydrogen for us at the appropriate pressure, and the compressed air comes from the little air compressor. And we'll come around on the backside and show you the connections on the backside as well. The gas station comes dry, and that's important for the shipping aspect of it. You certainly don't want water to freeze in the gas station. And essentially what you have here is a vent for the hydrogen in case of an overpressure situation. Here's the outlet, high pressure hydrogen outlet, that will feed the back of the CALIDUS gas chromatograph for both carrier and the detector. On this side we have the air compressor inlet, and this is the outlet. And in this case it delivers both the gases required for running an FID GC. It has sufficient pressure and flow to not only supply the oxidant, but if you have any valves for switching involved, it can provide the pneumatics for that as well. It's a gas station as opposed to just a hydrogen generator because it also includes the capability to make zero air, and by that we mean air that is hydrocarbon free, moisture free, and fully a good oxidant for the flame ionization detector that has very good sensitivity. Well, it's all pretty easy. You can see we have our little compressed air station is on top of a cardboard box. This doesn't weigh a ton. It's fairly light, and it does produce a nice level of compressed air. And I'm just going to switch it on so you can see and hear how nicely this little workstation works. And you can hear the air is flowing. I'm going to put a little pressure on here, and it builds up pressure in a little tank back there, and sure enough, there's compressed air. Next thing we need to do is to connect the fittings, and we've connected it to the air station, the gas station up here, and we need to put a wrench on it. We need to make it reasonably tight. It has to be leak free, and we'll check all that. Okay, now we have compressed air going in, and we have connected a utility to be able to operate 2 gas chromatographs off this workstation. And what we have is high pressure air coming out. We're going to set it at about 50 psi, and we're going into a T, and each one of these T legs is going to feed a gas chromatograph. And CALIDUS is a pretty low utility device, so we're using just temporary 16th inch Teflon tubing. In the laboratory, in a permanent installation, you probably want to use something like PEEK or actually even stainless steel tubing for this. But in a demonstration mode, this test rig will work just fine, and next we need to plumb the hydrogen. Okay, for hydrogen we have a similar situation. There's a little bit more to it than on the air side. We've connected a hydrogen line that has plenty of flow and pressure capability to yet another T, and we're using the T here, this brass construction, because we actually had 2 gas chromatographs we're going to hook up this morning. And so one leg goes to another kind of a T, one for each side. And the question is, why does it look so funny? And the answer is CALIDUS has the capability of using a flame ionization detector, which does require hydrogen, but there's the option for a separate carrier. And for the applications we're doing this weekend, we need hydrogen for both carrier and the detector. So we have 2 leads that will feed the input to the gas chromatograph, and we'll show you that in just a moment. And so we're ready to go with hydrogen, and we're about ready to start plumbing an instrument.